Alright, this is our next notes for Algebra 1. This could be lesson, as you see here, 4.4. And this is going to be on scatter plots and lines of fit, or lines of best fit. So first we have to come up with some explanations here. And the first one we have to do is, well, what is a scatter plot? And you might kind of know what that is already. Scatter plot. And this just to describe it, it's a graph using a coordinate plane. So we're going to use a coordinate plane like an x and a y coordinate plane. And then it's going to graph two variables are then placed in the plane. And it's kind of like a graph that you're going to think. I'm going to show you some examples here in a minute. And really in that coordinate plane we have ordered pairs x's and y's. And we just graph them on there and we see what they look like. We call this bivariate data. So if you see that term, that's really just referring to taking some data points and putting them into a coordinate plane and see what it tells us. A lot of times, though, another name you might see with this entire graph that we make is called an association or correlation. So we're really comparing two factors, the x and the y, and see how they're related to each other, and see if there's, when we plug those points in, do they have any kind of specific behavior. Okay, so then we can do that. Here's some examples of what I'm talking about. So if each one of these dots here was a data point, just round these in really nice, then we would see something happening. You should kind of notice it as you're looking at the data here. You should see that it's kind of going up. And if I put a line in here, I'll probably put a line like right there. And just like the slope of a line goes up is positive, if the data sets that we see, or the association or the correlation we're looking at, if the data is going up, that's called a positive correlation or association. If we then continue some other examples, we have one right here. This is a negative, and we could see that. We could put a line right in here, and we would see just like a slope that goes down is negative, this data set, when it's going down like that, is negative as well. You could also see finally really no up or down behavior at all, and we would call that no correlation. So that's a negative correlation going down. This is no correlation. You really couldn't draw a line for that. And the other one is your positive correlation, where it's going up. Okay. Now, as you've seen, I've been drawing lines in here. And we call those lines that, a line to the closest to all the points. We call that a line of fit. And it helps us predict behavior. It's also going to help us do something else. So, but that's a line of fit right here. And you could figure that out if you use Microsoft Excel. It can put it in there for you, and so on. So then we'll see in a minute how we're going to use that. But so what we can do, though, is we can use those lines of fit to determine a linear function, okay, from a scatter plot. And the steps to do that is we just make our scatter plot, put all the data sets in. We don't worry about a line yet, but then we add the line of fit. So if we had this kind of data right here, it's negative, we could see it's coming down. We could find out where the best, or predict where that line is in the coordinate plane, and then add it. And then we could pick any 2 points on that line and then determine the equation or the function for that line. Okay? And then we could use the line to make predictions. And I'm going to show you an example here of what I'm talking about. So here we have some data. We have years since 2009. This is 1 year, 2 years, and so on. And then we have muscles. The muscle population is what we're talking about. So in 1 year since 2009, the first year it's 15,000. The second year, 125,000. It's just increasing a certain amount. And we're going to use this data. We're going to make a scatter plot. We're going to put a line of fit in there. And then we're going to see how we can use it to make predictions. Okay, so let me set up the graph here. So here's our setup for the graph, and we're going to add our data. So if we just show you this data, I'll put it underneath, and we can kind of put it into the graph. So in year 1 we had 15, so it's going to be somewhere down around here. We're just going to estimate it. Year 2 we have 125, so that's about here. Okay, year 3 we have 175, somewhere like here maybe. And then year 4 we have 225. It's somewhere about here. Year 5 we have 325. And then year 6 we have 435. and then year 7 we have 483. So almost 500, somewhere around there. Okay, so you can kind of see we have some data, and then we don't really have a straight line. So if we were using a computer, we could just tell the computer to put our best fit line in, but we're not going to do that. We're just going to use a ruler, try to take a good guess about where that line is. I'm just going to put it somewhere around here. Okay, so like that, and then there's our line, and we can then maybe make some predictions if we keep going with this, right? So we could say this is year 8. Let's have it 2 years later. If we just follow it up to where it crosses that, we can't quite get there. We'll go year the next year. We'd go right to here. That'd be that. We could come across, and we would say that'd be 550, a prediction there. Okay, and then what also we could do is we could just make a graph for this line. So we could find some good points where it crosses. How about right here? Call that A. Let's find another one where it crosses nice right here. We'll call that B. Then we find out the points for them, right? So this is 6, and then this is 400. And then we have B down here. It's going to be 2, and it's going to be 100. And then we can use these 2 points, and we can figure out the slope and all that of this line. Okay, so the first thing we want to do is the slope, right? So we'll just do that right here, actually. So we know the slope is the change in y over the change in x. So we plug that in. We'll call this the first y. It's 400 minus 100. Then it's going to be 6 minus 2. So then we're going to get 300 over 4. And then that gives us the slope. We can probably take this in half. 150 divided by 2. We could say a slope of 75 is what it would be. So then that's m. So then we can then take, we now have a slope, and we even have points. So we can then take our slope-intercept form, or point-slope form, y minus y1 equals m, and we'll just call it 75. Times x minus x1, okay, and we'll plug in. So y minus, we'll just use this point over here, minus 400 equals 75 times x minus, we're going to get that point 600, or 6, I'm sorry, not 600, 6. Then we're going to do the math. We'll leave the 400 where it is right now. 400 equals 75x, because we're going to distribute, and 75 times 6 is going to be 450. So minus 450. And then we just add 400 to both sides. And we're going to get y equals 75x minus 50. Okay. So then we can use this if we want to know data for other years. So we could keep drawing a line, but that's only as good as the graph or the coordinate plane, right? But this helps us predict whatever, because we know x equals the year since, and then in y will tell us how many muscles we'll have. So if we plug in 1, we'll be able to figure out the other one. So if we plugged in 20 for for the muscles, or I'm sorry, the year. So if we want to plug in 20 years after 2009, we plug 20 in for the x. We do the math, and it'll tell us how many muscles we'd have. So that's kind of an example of that. Let me know if you have any questions. And in that process we were talking about just figuring out if we just use this equation to figure out how many muscles or what the data will be in other years we haven't figured out in the graph. That's called extrapolation, something outside our data set. But we could also figure out something inside our data set. So here we have years 1, 2, 3, and 4. We could also use this equation if we went to half a year. So 2.5, half the way through, how many muscles would we have? Or half the year, halfway between 5 and 6, how many muscles should they have had? And use that as well. So that's called interpolation, and we have extrapolation as well, which is data outside, where you go beyond the data set. And that's kind of your notes. Make sure you add that to your notebook, and I'll see you in class.